LabView and MATLAB integration to Versatile Test Tree Studio webinar. In this webinar, we're going to walk you through how to use LabView and MATLAB within Versatile Test Tree Studio platform. The user would be able to perform the following key innovations within Versatile Test Tree Studio. Standardize the creation of test cases. Be focused on test plan strategy. Maximize the reusability of test modules. Reduce the time to develop the test automation plan. Simplify the maintenance of test spec and the adjustments. And finally, share your ideas efficiently with more people and improve the test automation process. The Test Tree Studio is combined of 4 main engines: Test Tree Manager, Test Tree Creator, Test Tree Runner, and Test Tree Presenter. As shown in this slide, these 4 engines communicate with a central cloud-based server to control the test stations. LabView and MATLAB are integrated with an advanced module to communicate with all standard interfaces in the market. The following are the key benefits of using advanced modules: flexible integration with third-party softwares such as MATLAB, LabView, or any programming language such as C#, C++, and C. The user would not need to program any code to integrate any of the above softwares within Test Tree Studio. This is an open concept design of test automation framework. All test results are forwarded to a unique single database. The user can do the advanced analysis of multiple test results. And finally, to enhance reusability and improve maintenance of test cases. In this slide, you can see the top-level architecture of Versatile Test Tree Studio Advanced modules. All these 3 modules are interfacing with the third-party softwares via inputs and outputs. Versatile MATLAB modules communicate with MATLAB software. Versatile LabView modules communicate with LabView software. And finally, Versatile DLL software communicates with any script and programming language such as C#, C++, and C. And the extracted results are sent to a central database. The 4 main sequences of using advanced modules. Step 1. Run your simulation through MATLAB, LabView, or create your DLL files on C#, C++, or C. Step 2. Create your process flow test cases through Versatile Test Tree Process Flow Management. Step 3. Using Creator, use MATLAB, Simulink, LabView, or DLL interface to create a liaison between your process flow and the external software. Once this liaison is done, using Test Tree Runner, you can run all the test cases that you have created previously and go through the test sequence for a pass or fail criteria. In this scenario, you can see all the test cases are executed one by one to be passed or fail. Let's see all these capabilities in the real world. using the LabView module. Let's run the LabView tool and create a dual channel VDN. The block diagram of this dual channel VDN has already been created to save time. Let's give the upper and lower cutoff frequency as the main input parameters to the tool. We are indicating 2000 as the upper and 1000 as the lower cutoff frequency to this tool. By running the tool, you can see the simulation result on the screen. Let's change the parameter and rerun the simulation. As you can see, the result has passed since the second set of parameters was within our spec. The next step is to call the test tree creator and start designing a test case. Click Add and provide a name to your test case. From the Advanced Module section of the tool, drag and drop the LabView module into your test sequence. Provide a module ID and spec ID to your test sequence. Call the dual channel VDN which has been created previously in LabView. Once the LabView program has been called within Test Tree Studio platform, in the property windows, all the parameters and settings has to be done. All the design requirements must be specified in the appropriate section of the tool. These sections are as follows: Settings, Arguments, Results, Post set, and finally the Advanced. Once all these parameters have been inputted into our tool, the test tree creator is ready to perform the test. Just press Apply and try it. As you can see, the same platform that we ran through VI can be seen within Test Tree Studio platform. All the cutoff frequencies are shown here and the results are passed. We can stop and move to the next level. The final results of our test case are shown with the green dots indicating that all the test cases have been successfully executed. Let's see how MATLAB can be used within Test Tree Studio. In this case, a MATLAB program called double amplitude has been created previously to save time. Let's perform a simulation within MATLAB environment and run the program which has been created previously. As you can see, the result and the scope are showing the frequencies that we are targeting. Let's close the MATLAB program and move to Test Tree Studio Creator. Within Test Tree Creator, click the Add button and create a test case. On the right side of the tool, select the Advanced Module section. Drag and drop the MATLAB module into your test case. Provide the module ID and spec ID into your design. In the Settings section, provide a file path to the MATLAB program which has been created previously. Select the program Double Amplitude and open the file. On right side of Test Tree Creator, there is a property windows which indicates all your design requirements inputs. All the design requirements must be specified in the appropriate section of the tool. Once all the parameters have been created, simply click Apply and try to run the tool. As you can see, the test is being performed and the same results have been shown on a test tree creator environment. The green dots are indicating that all tests have been successfully performed and there is no error with your design. Next, in a standard section, drag and drop the data module into your test case. Provide a description and import the data from the file. By clicking Launch, the tool brings you to a secondary environment where you can open your file. Browse to your text file and click Open. At this level, all the coordinates have been imported within the Test Tree Studio Creator tool. Select the coordinates and choose from the known separator. Once this step is performed, the next level is to extract strings, which brings you to the column data. All the coordinates have been in the same spreadsheet as Excel and ready to be executed. The last step is to process the data. Simply select the Process Data section and provide the appropriate input and click Add. Select the design, provide the spec ID and the type of a comparison with a minimum and a maximum parameter. In the setting window, select all setting as your main input. Once this is done, click the button Try It, and the results of the outputs are shown in the process window just below. Select your design and upload your test sequence file. In this last section of this presentation, we are going to show you how to run your test using Test Tree Runner. In Test Tree Runner, click the button Open and scan when you are ready. By pressing OK, all the test cases that you have already created are going to be shown on the right side of Test Tree Runner. In the pre-functional test, select the test case that you want to run. By clicking the Run button on the Test Tree Runner, you would be able to perform a series of tests that you have already created. Once the test is performed, move to the next level in MATLAB simulation environment. As you recall, the test case number 2 was the block diagram of 2 channels VDN which was created with MATLAB. We are seeing the results of this test case that has been created previously in the runner. As the final results, Test Tree Runner is indicating that both test cases, test case 1 with LabVIEW and test case 2 with MATLAB, has been successfully performed. This concludes our fourth video presentation and webinar. For any other questions, please refer to our website at www.versatile.com. Thank you.